Hi, in this video I'm going to talk to you about a type of data structure that's used in programming called a record. A data structure is simply a way of organizing data so that the programmer has an understanding of how the pieces of data relate to one another. The reality is that all data is stored in storage locations in RAM. Each location has its own unique address. And a data structure is simply a way of allowing the programmer to conceptualize or imagine how the data is organized. In this slide, I have 5 one-dimensional arrays. This is one of the simpler forms of data structure. So in this particular data structure here, I have a one-dimensional array and they hold the names of stock items. So if I want to talk about hoodie, that would be name square brackets 3, or sweater would be name square brackets 7. And similarly, I have a one-dimensional array of integers, which is the number in stock that I have of each of these items. So I've got 11 hoodies, and each hoodie is £25.99. And I have a little graphic or image of the hoodie, and the image ID is 1013. And this array is an array of booleans indicating whether or not the item is currently discounted. So we have 5 data structures, 5 one-dimensional arrays of various different data types. In main memory, these would just be stored one after the other, followed by the number in stock, followed by the price, and so on and so forth. So this way of arranging the data in these data structures is purely for the programmer to be able to imagine or conceptualize how the data relates to each other. Now, this isn't particularly useful because all these pieces of data are connected together, but they're sitting in their own individual data structures. And there are lots of reasons why this isn't a particularly good arrangement, but perhaps the most obvious one is that if I wanted to carry out an operation on the data, so for example, if I wanted to order them, so like sort them into order, say I want to know which ones have the most in stock, so sort them on number in stock order, then the module to do that, I would have to pass over this array and this one and this one and this one, because I don't want to just sort the number in stock. I want this data and these pieces of data to travel and follow the same ordering. So you would end up passing over as parameters this name of the array and this one and this one. So you've got 5 parameters to pass into the module just to be able to sort, say, on that particular part of the data. And in fact, in real life, these stock items probably have a large number of attributes or fields, if you like. You know, you could have the manufacturer of the hat and the country of origin and whether or not it can be delivered. So this only shows 5 arrays, but in fact there could be any number of pieces of data. And to pass all those pieces of data over to one module suddenly becomes very unwieldy, becomes very unreadable, and it can be quite unreliable because it would be quite easy to say to miss off passing over all the bits of data. You know, if you are passing 5, 10 or even 15 parameters, it would be quite easy to miss out one of them, and then before you know it, your data has become unreliable. So a much better way of organizing this would be to organize it in one large data structure that has one name, and that's stock item. So if we go back here, we had 5 different data structures. They each had their own name. And on this slide, I have one single data structure and it is just named stock item. And these words here that were the names of the arrays have now become what are called the field names. So I have in stock item, I have 1, 2, 3, 4, 5 fields in each record of data. And there are in fact 1, 2, 3, 4, 5, 6, 7, 8 records of data. And as you can see, this is a relatively simple situation here. If we were talking about all the items of clothing that might be on sale on an online store, you're talking about a massive data structure with a massive number of fields. And in fact, you might have other data structures that are linked into it. So we have stock item, which is a one-dimensional array of records. So this record here is stock item 1. This is stock item 2, stock item 3, and so on. So it's still a one-dimensional array, but each element is a record with 5 fields. And in some languages, you need to actually define that type. So here I've got a record type definition. So I'm defining a type of record that's got 5 fields. One is a string, an integer, a real, another integer, and a boolean. And then I might be expected to show the end of the type definition with this sort of end statement. And that's quite typical of a number of programming languages where you actually have to define your type. And in a way, it's like you're able to define your own type of variable. Integers and reals and booleans and strings are common to most programming languages. But what I've done here is I've defined my own type of data structure. So down here, I can now say what type of array I want. So I'm defining my type of array. And I'm going to say that I have something called an array of stock. And actually, I want to put an equal sign there. And I say that it's an array 1 to 8 of stock item info. And that word there is the word that I named the record with. So I'm saying that I have a type of an array, that's got 8 elements, and each element is one of these record thingies. So now I'm able to actually declare my array as an actual variable. So this array here is a variable in that its contents can change. So I say that stock item, that's the name of my array, is going to be an array of stock. And here I've said that an array of stock is an array with 8 elements, and each element is one of these records. So that's quite long-winded, but that's something that you have to do, as I say, in a number of programming languages. If we go and look at how that might be used, here's our one-dimensional array with our 8 elements, and each of the elements is a record with 5 fields. So if I want to read in, say, the names, the way you do that this is Pascal, the syntax, that's how you write the statements. The syntax for record use is this dot here. So I'm saying for I is 1 to 8, which allows me to count down the rows in the array. For 1 to 8, do, and this is read line, which is just, getting input from the keyboard. Stock item I, so the first time around it'll be stock item 1 dot name. So I'll be able to type in hat, and then it'll go around for 2, read in stock item 2 dot name. So there. So if I'd wanted to read in, say, the price, I would put read line stock item I dot price. So this part of the syntax is the name of the field. And similarly, if I want to display the values, this is a write line in Pascal, I would say for I equals 1 to 8, write line stock item I, and this is going to write out all the prices. So if I'd wanted to write out whether or not they were currently discounted, instead of price, I would put the name of the field, which is currently discounted. This one here, I'm using a running total. So I'm saying total becomes equal to total plus, and I'm adding on the values that are in that field. Down here, I'm asking about stock item I, so each of the elements of the array, dot currently discounted. So I have an expression here, stock item I dot currently discounted, which is going to evaluate true or false. I'm saying if this thing is true, then this is adjusting the price to 90% of the price. So if this evaluates to true, then it will do this calculation. And if this evaluates to false, then it won't do this calculation. This last example over here, I'm actually writing the data out to a file, and if you've watched the file handling video, you'll know that the sort of sequence of steps is, first of all, I make a link between a variable within the program and the path to the file. I open the file for writing, and then I need to loop down the elements in the array 1 to 8, and I write line stock item I dot name, and this F here is I'm writing it out to the file that's been named as F. So it's going to travel around this loop 8 times, stock item 1 dot name and the number in stock, so on, and then the second one, and so on, and then I close the file. So make the link, open it up for writing, close the file. So those are statements that are written in Pascal, and I have a different variety of statements here. I have fixed loops occurring in each of these. I have a fixed loop. This is a condition that will evaluate true or false. This is an assignment statement. I'm saying the price becomes equal to this, so I'm assigning the value of this to that variable. And I have input and output. So let's go and have a look at it in LiveCode. Now LiveCode manages record structures in a slightly different way. It uses the square bracket notation. So it looks a bit like a one-dimensional array, and in fact that's how LiveCode manages these sorts of data structures, is by just simply making it a collection of one-dimensional arrays. So this is my fixed loop going from 1 to 8. I'm asking to enter stock item name, and I'm going to put it into stock item. So here's my one-dimensional array 1, 2, 3, 4 and so on, coming from I, and then the field names are put in square brackets inside quotes. So in Pascal, the record notation or syntax is the dot followed by the field name. In LiveCode, it's square brackets with the field name in quotes. So here I've got another example, fixed loop, putting stock item I, price, so I'm getting all these numbers appearing in a field. Oops. This one here, this was my running total, where I'm putting what I have in my total plus the number in stock into total. And here is my calculation where I did 90% of my price as my discounted price. And again, if this evaluates to true, so we've got stock item I, maybe it's stock item 3. I'm going around here, 1, 2, 3. So stock item 3, currently discounted. Let's go and have a look at it. So stock item 3, that's false. So it will not do that calculation. This last slide is just showing you how you might write the data from the data structure. And again, this is just you as a programmer imagining or conceptualizing how the data is organized. This is writing the data from the data structure into the file. So this is me making the link. This is the variable file choice, which is now being given the path name to the file. I open the file for writing, and then I write each of the values of the array, each of the field values. So that's for stock item 1, and then stock item 2, and so on. So in fact, I'm going to have 40 pieces, all 40 pieces of data written out to the file. And then I close the file. I'm going to stop there, and the second video will actually look at a LiveCode program to use these records. But before I stop, I'm just going to revisit the idea of why these are so useful, this type of structure. It looks a little bit like a two-dimensional array. We have 8 elements to the array, and we've got 5 fields. But the difference is that an array should have elements that are all the same type. And a record structure allows us to have different types of values. So I have this record here, and the same type of record here, and the same type of record here. So in fact, we do have a one-dimensional array with the same type of element. And we're doing this because if these were all individual arrays, passing these in as parameters to modules would be very unreadable, quite unreliable, and it makes much better sense from a readability point of view and a reliability point of view to pass over just one parameter, and that is a reference to the entire data structure. Thanks for watching.